Hey YouTube, it's JP Dillon. Today we're looking at a 1987 Toshiba model cf-2036. This is one of the FST series standing for flat screen technology, although looking at it from the side, it is far from flat, but it is flatter than most of the competition at the time, minus the Sony Trinitron. This one is kind of one of my bucket list TVs. A friend had one of these growing up. We played lots of video games. Lots of memories with this set. Now, unfortunately, there aren't very many of these around, at least not these parts. These were common to have vertical failures, anything from non-linearities to foldovers to complete loss of sweep, and this one is no exception. And since a lot of these were small enough to haul into a trash can, they disappeared. And this one I got from the original owner. It's in very nice condition, but it was kind of the same thing. About maybe 7 to 10 years in, it had a vertical failure, and they just stuck it in the closet and forgot about it. So I did get the remote and everything with it, which is cool. And let me show you what the failure is that's very common to these. We're not going to leave this on very long, but you can see massive vertical failure there. So that's pretty common. Now this is a nicer set. It's got the fold down controls here. We can switch between TV and video. It does have a composite video input. The CRT I have not tested yet, but given how bright it is, I'm guessing it's in pretty good shape. So let's crack it open and I'll show you usually what goes wrong with these things. Alright, so here she is with the back off. Chassis slides out by means of these two clips here. You just pull them to the side as you pull out the chassis. Pretty simple. And everything kind of comes out for easy service. Now this is got loads and loads of bad caps. That I believe there is your vertical output IC. It's hard to tell here in this light what it is. Still hard to tell. Hopefully the chip's not dead. It's really just a complementary push-pull output, which is readily available. You can see this one's got some hours on it. The darkened areas of the board indicate lots of heat. I have a strong suspicion that the majority of these electrolytic capacitors in the sweep section are tired or just plain old dead. That's usually what causes the vertical sweep failures, is the capacitors in the wave shaper and output circuit. So we're going to grab the ESR meter and start testing these ones, but I'm pretty sure the majority of them are dead. At worst, we'll have to replace the IC too, but that's not a big deal. So let's get the board into a serviceable position and make some markings and start checking stuff. And here's the bottom side of the board, which you can see is pretty well baked, especially again around those resistors, so we'll need to resolder all those as well. It's pretty ugly looking, but that's just kind of the norm for these. So I'm going to mark all these electrolytics here, and then we'll check these ones up in the power supply too, because I'm pretty sure a lot of them are about on their way out. Other than those sections, the rest of it doesn't look too bad. The neck board doesn't look too bad either. It's looking okay. Alright, let's start marking stuff. We're going to see if my suspicions are correct here. I've got my capacitor wizard hooked up. I don't know why my lens is so hazy. I've cleaned it like 6 times, and so there's something else wrong with the sensor that causes the hazy effect, so I apologize for that. That one's alive. That one's alive. These are all the main power supply electrolytics. Let's see here. Yep, that one for sure. C332 is dead. Make a note next to that one. That one is for sure dead. 312, that's about on its way out. Okay. Then we got this other one over here in the driver. That one's about dead. So far it's pretty much what I thought it was. Hopefully the IC didn't get hurt. Usually what happens is something goes awry and the capacitor, leaky capacitor, causes the IC to fail. That's what I don't want, but yeah, so far those capacitors in the output stage, that's a film, so that's not going to register. And we got this here. Yep, C612, that's about dead. All in that high heat area, which doesn't really surprise me. And then we got this down here, C618, that one's about dead. So pretty much everything around this area here that we had identified as being overheated, everything in this area, all these capacitors in this area are just dead. The power supply ones seem to be okay, but everything in the vertical sweep section here is just flat out open. So that doesn't surprise me. So I need to take some quick notes of what these guys are, and then we'll change them out. Alright, so got my little map of what they are and where they are. So I'm just going to go ahead and start desoldering things. Take all the caps out that we've identified as defective. And then we'll stick new ones in. And here comes the boring part, which everybody loves. And normally I kind of hate on these big monolithic board designs like this, but this one's actually really easy to service. Now, about the only difficulty we may have is if we still have nonlinearity failures, and that's usually due to small capacitors off of the jungle which control the vertical, which I may just check anyways. Might as well just do a one and done. But we will check our work here after replacing these capacitors for the vertical output stage and see if we at least get our height restored. We may not. I just know for certain that these are in fact defective. So we're going to change out what is obviously bad first, and then we'll work on the other stuff, which is maybe of more importance, which is as yet unseen until we take care of this mess. And while I'm in here, I'm going to solder these connection points here that are pretty toasted. Might as well do that while we're in here for sure. Now, some years ago, I did a video on a Toshiba that was a professional grade monitor that didn't have any service literature, and we had vertical nonlinearity problems and stuff like that that turned out to be in the jungle IC, which we chased our tail a bit for. So lesson learned, and I'm definitely going to check that too if we still have problems after this. I'm not sure if we will or not. I don't know if you guys can see where I'm at, but over here there's a couple questionable connections off these power resistors that I'm going to resolder, just to increase our reliability factor a little bit, because they need to be done. Alright, looking around here, I don't see too much more that needs attention. Alright, so this could be tricky. I'll try to flip the board over so so that you guys can see enough of this that I'm pulling out. So this is the section that I'm working with. And it's kind of hard to see, and I don't really have another option of moving the camera. So I'm just going to start yanking these out. We just soldered them. We know what they are and where they go, so we're just going to take them out. That one's already fallen out. Maybe I missed one here. I think I missed that one. Let's move this aside here just real quick. Turn this back over. Oh yeah. Yeah, I missed the one over here. 22 microfarad or whatever it is. All right. That should give me enough leeway to yank it out. And we'll start replacing them. Let's see if you come out nice and easy now. Appears as though you do. And I'm just double checking here. Certainly looks like a 22 microfarad. All right. Well, let me go get our new caps and we'll start inserting them. All right, so we've got one installed there, and I had to make that out of 2 values. So yeah, that's why it looks a little funny. These other ones should go in here fairly straightforward. Let's see, we got a 33. And a .47, which went back here. And again, this may not completely fix everything. We're probably still going to find that there are more dead caps, especially around the jungle where the vertical waveform is. And I can look up the jungle, which is a TA-8677, and we can find out what the vertical pins are and trace out where they go and figure out if those caps are in fact defective, which it wouldn't surprise me, because that's kind of a thing on these Toshibas. Bad caps galore. And then finally here we have our 22 at 50. Push that back down a little. And then we'll rotate this. And we'll solder this all down here. And we'll slap it back in the set, turn it on, and see how well we did. Or if we still have more troubleshooting to do. And knowing my luck, I'm going to have more work to do, but at the same time, I won't be surprised. Take off the excess leads. I save the really long ones for other things. They make good board jumpers. and you got a crack in the board. Alright, brush my hand along there, make sure there wasn't any sticking up I couldn't see. And let's go ahead and put the board back in. And we'll fire up the set and see if we have a full screen raster or if we still have some more trouble ahead of us. Let's see if I can move this aside a little bit, get a better idea as to what we're doing. Or if this is just not going to cooperate, we'll find out. So we'll hook up our speaker. We'll attach our neck board. And then there's another cable for the power and the front panel here. And we'll just slide this back in. And we'll see if we get it right. Okie dokie. Let's check it out. Alright, moment of truth. Better. So we still have our non-linearity problem, but at least we have deflection. Nice bright raster too. Alright, so we have a little more troubleshooting to do. Let's look at that jungle IC and see what pins the vertical is associated with. We're on our way there. This is the chip we're going to look up. So far, I can find no data sheets online. I'm also not finding any luck in my 1990s ECG book either, because it doesn't go up that high. We go from the 7900s, let's see, pretty much to 198, so we jump over that, so that's not going to be of any use either. And pretty much nobody else has a service manual other than Sam's, so we may end up just downloading the Sam's to see what we need to do next. If I were to make an educated guess, since this has a lot of IF stuff in it up here, and this has more decoupling down here, my thought would be is that these capacitors here are probably in the wave shaping section for the horizontal and the vertical. There's probably a good chance that they're wasted or leaky. Those two caps I overlooked here, I didn't get this one tested properly, this 316 or whatever it is. This one doesn't test very good, and neither does this one, so let's pull them out and double check them out of circuit, because I was getting kind of erroneous readings, but they may be defective, and they be our remaining two. I went over the capacitors with the ESR meter that were in the section here on the top side next to the jungle where I would think that the sweep circuit pins would be, and they all seem to test fairly the same. They're all 10 microfarad, they all test the same on the ESR meter, so the probability that they're bad is probably small. And again, it could be that our vertical output IC got injured and we may have to replace that too, but for now, for sure, I want to replace C316 and 446, both of which test very marginal and fluctuate. So let's get them out of the circuit first. So the 10 microfarad at 250 volts is okay, but I have one so watts out, might as well just replace it. But the 22 microfarad here, if we just attach the leads here, if I can do this easily one-handed, probably not. It barely registers, if at all, so that's got to go. And we'll check and see where that circuit traces to, because that could be something we missed. So I have the two additional caps that were marginal replaced. The 10 at 250 was a B-boost cap, which probably won't affect vertical. However, C316 there does decouple the power supply to the vertical stage over here. So that might be a reason why we were having issues there. But no way to know until we fire it up. everything in that section that was defective, or at least found to be defective, has been replaced. So we'll find out. Alright, so let's see if we made any improvement here. I'm going to guess no. Interesting. So we actually lost some sweep here, but we gained some linearity, which is weird. I'm going to turn this down a little bit. It's just so bright. Run it for a little bit. And we got jumpy. Let's see what it looks like when we hook something up to it. So we definitely have some height, some linearity, and some convergence errors. Let's see if we can correct that a bit. That's pretty awful. I hate inline convergence jobs. They're just crappy. Those are still stuck together. So that red and blue or whatever definitely is a pisser. Getting ahead of myself. Alright, so if we bring up the height, which is this guy, let's see if we can get any better result out of it. I doubt it. I'm thinking there's more going on here than, yeah, so that's the maximum height you get. And we've got non-linearity issues. So either the vertical is trash, the vertical output's trash, or we need to shotgun that section off of the jungle IC, which controls it. Now the SAMs is about $22, and the amount of time that it takes you to figure one of this out is slightly longer. So you have to debate whether you want to spend the time this is awful. Okay, so I got the vertical right. Can we get the horizontal right? I'm just making it worse. That's a no. Let's just move this all back to what it was, which was just crap. Oh, we've got more shifted magnets over here. So this whole convergence piece here has been messed with a bunch. CRT needs a little tweaking on the green screen. That's better. That didn't take much. Focus is pretty good. That cleans right up. It's a hot CRT, that's for sure. But we just need to deal with that wonderful non-linearity. Once we take care of that problem, then it should be a good set. See what she does now. We were shotgunning all those capacitors in the jungle section. But I'm going to go with no. And I now have no brightness or contrast, so made a mistake there somewhere. Got OSD but no video. Alright, time to grab the SAMs and just figure this one out. Alright, so I need to backtrace my steps and figure out where we lost video. Probably a soldering error of some kind. But anyways, here's our vertical section. And you can see it comes off of pin 54 of the jungle IC, goes to the C30922 microfarad, which we have replaced, and it goes to this vertical amplifier 2SC1815, goes through a Zener diode, which is probably like a 5-volt Zener diode, and then we're supposed to have 1 volt peak to peak of vertical pulsing at pin 4 of the output IC. And 5515, that's a Panasonic part. So we first need to get our video back, and then we need to figure out where in this chain is the deficiency. If it's the jungle IC and we've got low output from the jungle IC, then we need to backtrack and figure out, based on this pin here, pin 55, which has the height control and whatnot. And then you've got the 2.2 microfarad, the 470 microfarad, and then C316, which we've also replaced, C308, which we've also replaced. I don't think we replaced C319. That is a feedback, I believe. But I figured if that was open, then we'd have massive height problems. So, like, excessively high, if that's a feedback. So we need to kind of figure out this circuit here after restoring video, and then we can figure out whether we've got sufficient input at the vertical out IC and the IC is just bad, or whether we've got more complicated problems in the wave shaper form of the jungle section, in which case that could be a lot of fun. We could have a 180 ohm resistor that's out, the 2.7K could be out, the supply voltage to the vertical amp transistor there could be low, a bunch of stuff. But now that we have this, we have a roadmap as to what we need to do. And although I like to, figure these things out on my own, it's also true that the schematic is the roadmap and you got to know where to go. So sometimes you just got to open your wallet and spend the money on the SAMs if you don't have it, which I didn't. So now we can continue troubleshooting and hopefully resolve all of our issues. So there's the mistake. While I was soldering C210, obviously I got a little blob of solder on 2 pins. Hope I didn't hurt anything. Let's just go ahead and correct that. Alright, the short is clear. So let's go back to what we were troubleshooting earlier. And so looking at the circuit, we've already replaced C309, C322, C312. What we have not replaced yet is C319 in the oscillator, which is part of a feedback network. That could be leaky or defective. We have replaced C316, so we need to check C319 and any surrounding resistors that may be high or open. And then the 2SC1815 Q302 is a buffer, probably a unity gain buffer, and its job is to feed into the input pin on the vertical output IC. We're supposed to see a volt peak to peak there, and then there's a Zener dial that helps regulate those pulses in the DC too. So these are all things that we need to look at. So let's start with the obvious, which is the capacitor, and then we'll pull and test the 2SC1815 and see if that is open, because if it's open, we would have very little to no input, which would explain the complete loss of vertical sweep even at maximum. So need to look at that too. And there's C319 right there, which I have not replaced yet. So let's go ahead and pull it out and test it for leakage and see, because it tested okay in circuit with the ESR meter, but the ESR meter won't tell you if it's leaky. It won't tell you if it's got issues. So there he is, a 470 at 25 volt. That's that big green guy. So we're going to check him for leakage. And we're going to use our W519A voltometer that puts about 22 volts across it. And we're going to see if it leaks. And if it does, it's getting changed out. Alright, let's go ahead and see if she's leaky. We'll just keep turning up the voltage until we get something. So there's our 22 volts across it, and basically it should be slowly charging up. And it is slowly charging up, very slowly. But let's compare it to a new one. And even after a minute or two, it really hasn't changed much. It's still kind of sitting there, so it may be defective. Let's go ahead and connect our new one over here. And we can see already it's charging up a lot faster. But it's slowing down too, so it may not be defective. But given how cheap a part it is, I might as well just put a new one in there, but I don't think that's the cause. So our next stop is Q302, which is that guy right down in there, right near with the capacitor we just replaced. Okay, so let's go ahead and get down there and pluck him out. Alright, there we go, 2SC1815. Let's put it on the component checker and see what it's good for. Alright, let's take a look, see what it does. That's about normal. Although the forward voltage is a little bit high. Let's compare it to a new one. The beta of 142 isn't bad, although I'd expect a little bit higher. But again, I don't think that's it. Alright, so let's compare this to a newer one. I know these to have higher betas, but I'm looking for the forward voltage drop. Yeah, see, like, that's more normal. Like 7/10 of a volt. I'm starting to see these populations of transistors where the forward voltage is going way up, like 800, 900 millivolts. And it's taking more energy to turn the transistor on than there should be. But I don't know if that would kill it or not. I don't think it would. Unless they really want that forward voltage drop. And this one's only got 5/10 of a volt across it, so maybe that would affect it somewhat. But yeah, so we can put the new 1815 in there just for grins and giggles now that we've changed it. We do need to check around these resistors here and make sure that they're all still within spec. So what we need to do is take a look at a lot of these value resistors that are in the oscillator circuit first. We're going to check in a couple next to the output IC, but I think we're really going to need to focus on the oscillator section. So we have this 33 ohm here, which is still very happy. You got a what looks like a 200 ohm, which is 197. 270. Is that what I'm reading right? It's supposed to be 270 ohms. It's measuring 100. Interesting. It's probably just in circuit noise. This should be like a 10 ohm. Nope, it's brown, black, gold, so definitely 1, so 1.2. And this should be like a 2 ohm. And then this over here should be like a 33 ohm. Assuming I can get to it. Oh, that's across L411, so. And then we've got this 390, which is still spot on. There's another 1 ohm. Yep, that's looking good. 120 ohms still measures 120. 110 ohm measures 108. So far, none of these are cranky. We've got this guy back here, looks pretty toasted. Measures 25K. Hard to tell what that's supposed to be. 1.5K. It's supposed to be 4.7. It's measuring 4.2. 2.2K. Yep, alright, so let's see what our... What is that? 413? I'm going to guess that's 413. Let's see what that is, because that one looks pretty crispy, and the resistance keeps going up. And if we just take a look here, measures 20, just a hair shy of 26K. Maybe it's supposed to be 27K, but better to validate than not. Alright, so that's supposed to be 2.7 or 27K, so that's pretty normal there. The next thing I want to look at, we need to look at the feed resistor going into pin 55 of the jungle, which is R311. It's an 82K. And the question is, probably going to have to flip the board. Problem is, I can't seem to find R311 anywhere. Got the 600s, got the 500s, 400s. And we get closer over here with 306 and whatnot. But I don't see none. Can't find it. See, my concern is that the voltage being supplied to that section through that 82K resistor is kind of low. And it's fed through the 82K, then through the pot from the 26 volt supply. Now the other thing is I wonder if the 26 volt supply is sagging because of some open filter. There's supposed to be a 1000 microfarad capacitor in this bank somewhere over here that's dealing with the 26 volt filtering. So I'm going to pull that out and check it and see if that's a capacitor that's still okay, because the ESR meter would register it as a 0, anything, 470 on up, but it needs to be at least 1000, so let's take that one out. So our 1000 is measuring 938, which is about 12% low, but that, I don't think that would cause that. So, but it's getting a new one anyway, so whatever. I think it's time that we put all this thing back to a point where we can troubleshoot it while it's live and see what's going on there, because this seems to be, pulling and testing components individually. It doesn't seem like it's that. So we really need to do live troubleshooting on this, otherwise I don't think it's going to go anywhere. All right. Let's see, now I got nothing. I had like we've got a vertical error. How nice. So now we have no vertical. God, what's going on here? Officially an idiot. I meant to grab a KSC 1815 and I grabbed a KSA 992. So, yep, that's not going to work. No, hopefully with the correct NPN transistor in there now, this will actually have deflection. Alright, so we're back to square one again. Of course, I still don't have any static on the screen. Oh, I hope I did not hurt that jungle IC. I think I might have, because we have no picture whatsoever. I hear the vertical chirping away. Yep, and I have screen if I crank up the screen, so. Oh boy. Yeah, this has turned out to be a bad one. Made a mistake that probably injured the set. We have OSD, and we still don't have adequate vertical height here. So not good. And I may have killed that IC, and that's not fun at all. It's just going to do its thing. All right. So I'm just very carefully looking around for any other screw-ups I might have made in my haste. And I should have better checked that. before applying voltage to the set, because there's a very good chance I killed that IC, and that's why we're not getting any feed through from the tuner. So far I can't see anything obvious. See, that was the bridge that I cleared. And you can still get that IC if you look, but it's definitely going to take a while. So this may have to be a project on hold. But yeah, just looking around, making sure there's no points I didn't clear. And we still got the issue of the loss of height, which we need to troubleshoot, but not much point in that unless we can get a video signal to the screen. How annoying. And it was all because I didn't take the time to double check the soldering when I replaced that cap. Too much in a hurry. So yeah, not good. So it looks like this one's going on hold until I can get a jungle. Sound but no video. That's true of tuner video. What a bummer. But people make mistakes, and this was a stupid one. So it looks like I had pin 11 and 12 shorted together. So I was shorting the video output to ground, which apparently hurt the chip. So that's why we don't have video. So we got to find ourselves a jungle IC, and then we can get back into this one. But for now, it's dead in the water. And they are available, and I bought from We Have That item before, and they're pretty decent. So that's going to be a genuine part and not a counterfeit. So the part itself isn't really costly. It's just the time to change it out and then making sure that you don't bugger it anymore like I did. So lesson learned, don't be an idiot and double check your work over and over again before applying voltage. So we're going to go ahead and replace this chip and then fire it up again and continue from where we left off. So very time costly mistake. If this was a customer unit and not my own, this would be a big hurt. And so I'd have an angry customer and definitely a kickback in the timeline. So, yep, got to be a little more patient. So we're going to go ahead and buy this guy, pop it in, and that'll be in the next installment. But for now, thanks for watching.